Hello dear students, today in this video I am going to start chapter number 4, structure of the atom. In chapter number 3, atoms and molecules, we have studied Dalton's atomic theory, which stated some postulates regarding the atoms. And in the Dalton's atomic theory, it was stated clearly that atoms are indivisible particles. So there are some questions in front of us and we should give the answer for those questions. If the atoms are the fundamental building blocks of all the matters and if they are indivisible, then what makes the atom of one element different from the atom of another element? We already learned the physical as well as chemical properties of the metals and non-metals. That is, the different kind of elements which are constituted by atoms of different elements show different physical as well as chemical properties. So how is it possible? And how the mass of atom of one element is different from the atom of another element? So there are many questions in front of us. So we can think, is the atoms are really indivisible, or is it divisible, or constituted by some another particles? And there are some natural phenomena regarding with the electricity which ensure or which strengthen these questions, because on the studies of the static electricity as well as the current electricity, we already learned in class 8, that is on rubbing of two objects between each other, then the particles, the objects get charged, and from where this charge comes. That means on rubbing of these materials, the both objects get charged means the atoms constitute of charges, and there are some charged particles present in the atoms. So we can conclude that atoms are not completely indivisible. Atoms also constituted by some charged particles. That is the result we got from this observation. So on the basis of this conclusion, scientists try to understand the structure of atom step by step. So here in this chapter we are going to study the main topics, that are what are the charged particles present in the atom as well as the different models proposed by different scientists. As step by first, it was proposed by the J.J. Thomson, and Rutherford comes and modified that model and he proposed for another kind. Again Niels Bohr took the model and modified and he proposes some other postulates. So we will study one by one in this chapter. So first let's start with what are these charged particles. Even before the discovery of these particles, their belief is already know that there are two kinds of charges, positive as well as negative charges. But it was not clearly known that from where this charge comes. Now, before discovery of the structure of atoms, it clearly mentioned that these are from the constituent particles of the atoms. So let's see what are these charged particles present in the atom. The first charged particles, that is electron. Electron is actually a negatively charged particle, and it was discovered by J.J. Thomson. It was discovered by J.J. Thomson with the presence of cathode rays. Cathode rays which consist of negatively charged particles. It's actually that experiment is not is part of our syllabus. But let's see the structure of this cathode ray tube. You can see here, this cylindrical shape is a cathode ray tube. This is the cathode ray tube. Okay, and this is connected to a high voltage, and here it is two electrodes. One is cathode and another one is anode. We already know that the electrode which is connected to the negative terminal is called cathode, and electrode which is connected to the positive terminal is called anode. So after, and he used a vacuum pump to evacuate the discharge tube and applied high voltage. On the application of high voltage, he observed that there are some rays which is generated from the cathode and it is moved towards the anode, and here he got the presence of these rays with the help of a fluorescent coating, because that is a typical type of coating which is used to detect the presence of charged particles. Clear. So this is the experiment is not the part of our syllabus. So just understand what is a cathode ray tube. Okay, and it is represented as E minus. Clear? Electron is represented as E minus because its charge is negative, and the mass of the electron is negligible compared to the mass of the proton and other particles. Mass of the electron is negligible. Clear? Its value is actually 9.11 sorry 11 into 10 raised to minus 31 kilogram. See, minus 10 raised to minus 30, that is 0.000. It's a very small value, is negligible compared to the mass of other particles. And now let's see the second kind of particles, that is proton. A proton is a positively charged subatomic particle. Proton is a positively charged subatomic particle. The credits of the discovery goes to Ernest Rutherford. Because never think that only the name of the scientists which mentioned here are take part in the development of the structure of atom and the discovery of the particles. It's not like that, because it's a hard work put together by many scientists, but the major contribution was given by the scientist name of the scientist's name here. Clear? And the presence of positive charge confirmed with the help of canal rays. Canal rays means anode rays. There are some rays which is some modifications done on the cathode ray tube, and the scientists go to the observation that some rays were moved from this cathode to anode. That means some rays were moved from anode to cathode. Such rays are called anode rays or canal rays. Okay, that is also not the part of our syllabus. Okay, so with the presence of these rays, he observed that some charged particles are present in that. Otherwise, there will not be any formation of such a charged particles rays. Clear? On the application of high voltage, and it is represented as P plus because its charge is plus, and its mass of it is almost approximately 2000 times as that of the electron. That is why I told you that the mass of electron is negligible, because mass of the proton is 2000 times that of electron. But the strength of the charge or magnitude of the charge of proton and electron are same but opposite in nature. That is, one is negative and another one is positive. But mass is not in the comparable range because mass of electron is negligible. Clear? Now let's see the first structure of first model of atom proposed by J.J. Thomson. The first postulate of this atom model is an atom consists of positively charged sphere and the electrons are embedded in it. That means diagrammatically we can represent like this. The blue sphere represent positive charge, positively charged sphere, and these electrons are embedded in it, or electrons. Clear? So this is the structure of the atom proposed by J.J. Thomson. He said like structure of atom is like this. And also the second postulate that is very important, the negative and positive charges are equal in magnitude. That means the strength of the negative as well as positive charge is equal. So the atom as a whole is electrically neutral. That's why generally the atoms are neutral. While it is rubbing, some charges from the atoms of one object will be transferred to the another object, because of there is an unbalancing of the charges present in the atoms of both objects, and this lead to the development of net charge in both objects. So as atom whole, if we take, that is electrically neutral because the strength or the magnitude of positive as well as negative charges are equal. These are the two postulates proposed by J.J. Thomson in his model of atom. It has a lot of limitation as it was not able to explain many experiments result. Let's see what are the limitations of J.J. Thomson's model of atom. The first limitation is the atom model failed to explain how positive charge hold on the electrons inside the atom. Because we already know that there is an interaction between negative as well as positive charges. That means there is an attractive force. And in case of same charges, like charges, there will be repulsive force. So, if the electrons are embedded in the positive charged sphere, how these electrons will be interact each other? Whether there will be repulsion between the electrons, and because of that the electrons will move from away and it is towards the edge of the sphere, or there is lot of questions arise. That means that those things cannot be explained. So that means his model nothing mentioned about the interaction between the charged particles inside the atom. Second one is that it was unable to explain the alpha particle scattering experiment of Rutherford. So these are the main limitations of the J.J. Thomson's model of an atom. However, his model given a step to the discovery of the structure of atom, even though it was not appropriate structure model. Okay, that's all. So let's see what is the alpha particle scattering experiment performed by Ernest Rutherford. Rutherford designed an experiment for knowing how electrons are arranged in the atom. That means Thomson just said only just are embedded in somewhere here and there. But how it is, whether it is properly arranged or is it same as the said by J.J. Thomson? He need to know. For that he arranged an experiment, and in this experiment, fast moving alpha particles were made to fall on thin gold foil. That means he took main two materials that are. So that means he used two materials. One is gold foil and another one is alpha particles. He selected gold foil because he wanted as thin as possible. Why? Because gold has high malleability. High malleability. It can be made into thin sheet and thin foil because its malleability is so high. Because of this reason, golds are used for making ornaments with small designs. Not only that one, gold is non-reactive with the oxide. That is another one. But one reason is that gold is highly malleable because it can be made into a thin foil. And this gold foil was about 1,000 atoms thick. That means the thickness of gold foil consists of 1,000 atoms. Okay, and the alpha particles means doubly charged helium ions. That is He2 plus. What is the atomic mass of the helium? Its atomic mass was 4U. So he took some heavy particle than the mass of the proton. So according to the J.J. Thomson's model, that was the proposed model. Right now we have. So according to his model, Rutherford expected some result, observations. What are his expectations actually? He expected that alpha particles would be deflected by subatomic particles in the gold atoms. That means all the alpha particles should be deflected, but that deflection should be a small, negligible one. Because the alpha particles were much heavier than proton. So the deflection should be negligible or small. Let's see the simulation of alpha particle experiment performed by the scientist Ernest Rutherford. This is the alpha particle source. Alpha particle source. This symbol represents alpha. Okay, alpha particle source. And this is the gold foil. Gold foil. And this is fluorescent plate. For detecting alpha particles, because alpha particles are helium ions, it cannot be seen by naked eye. So to detect the presence of alpha particle, he used fluorescent plate, and while the alpha particle hits on this plate, there will be a flashing of the light. So we can observe that alpha particles hit that portion. So this is the way he set up the experiment. Let's start the emission of the alpha particles. So you can see that most of the alpha particles, large number of alpha particles, most of the alpha particles are moving straight through the foil without any deflection. That is the first observation. And you can observe that here some alpha particles are deflected by the gold foil by small angle, And very few alpha particles you can see. You may observe that rebonding here. Here it is sitting. Rebonding to here. That means going here and rebonding. Out of every 12,000 alpha particles was rebonded. That means one of out of 12,000 is calculated by observing for a long time. Okay, we will not get it exact number. So this is the observations we have got. Clear? Let's see the zoomed view, how it is diffracted. You can see like this. No. Some particles are going backward also. No. Some particles were going without any deflection. Some particles going with a small deflection. Some particles are rebounding. Okay. So these are the three observations he got. Okay. Then he arrived at some conclusions on the basis of this observation. Let's discuss that. What was his conclusions? Three conclusions on the basis of three observations. So most of the alpha particles passed through the gold foil without getting deflected straight, which means most of the space inside the atom is empty. That is a conclusion he got from the first observation. Most of the alpha particles pass straight through the gold foil without getting deflected, which means most of the space inside the atom is empty. The second observation was that very few particles were deflected their path. Some of the particles were deflected by path. That was the second observation, which means the positive charge of the atom occupies only a very little space. So while that particles moving through that space, it is getting deflected. So only very few particles were getting deflected means only the positive charge of the atom occupies in a small region. If it is a charged sphere, then it should be all the particles should be deflected. But positive charge occupied only in a little space. Because of that, the very few particles are going through that space. Only those particles get deflected. That means let's compare his expectation and the exact observation. This was his expectation on the basis of Thomson model. That is, all the particles should be going through the atom with a negligible deflection. That means and deflection not to be observed actually. This is the expectation was by him, because positive charge is distributed through the sphere. So all the particles going with a negligible deflection like this, very very small deflection, but it is represented as an arrow line itself, a straight line itself. But he got like this. According to his observation is that majority alpha particles are going without any deflection, and some are deflected by small angle, and some are debonded. This observation on the alpha particle experiment not able to explain by Thomson model. And the last thing is that a small fraction of alpha particles were deflected by 180 degree. 180 degree means not exactly 180 degree, okay. This is almost like a 170, 160 only. That means more than 90 degree. It can be 100. So, for example, alpha particle is going in this direction. If it is deflected like this, this is less than 90 degree. But if it is deflected like this, then this angle you can see it is more than 90 degree. So when it is deflected in this direction, it will become 180 degree. Clear? So in the range of 180 degree, okay. It's not that all the rebounded alpha particles are deflected by 180 degree. It's not like that, okay. Indicating that why only few alpha particles were rebounded, because it hit on a heavy mass. You see, while you throwing a rubber ball on the wall, what will happen? It's rebound, because the mass of the wall is much greater than the mass of the ball. So this very few, that means a few fraction, that is 1 out of 12,000 alpha particles rebound means the mass of the alpha particles we know that is 4u. But the place where this few rebound alpha particle hit, the mass of that region is much greater than the mass of the alpha particle, which means mass of the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. So whole mass of the atom is concentrated in a small region, and if one alpha particle hit that region, it will get rebound. That is what he keep showing here. And it is this red region is representing the mass and positive charge of the atom concentrated, and when it hit, it is get rebonded. But the other spaces are empty, so it can be easily moved through the atom without any deflection. See here in the textbook also one diagrammatic representation is given. See, this is the atoms, the layer of the atoms of gold foil, and alpha particles. Most of the alpha particles are moving without any deflection because this space are empty. This one circle is representing one atom, and this dot representing the mass and the positive charge concentrated in a center and small portion. So when it hits near when the alpha particle is moving near this region, positive charge, it is getting deflected. When it is exactly hit on the mass, it is getting rebounded. Clear? It is getting rebounded. But when it is moving near to the alpha part, this concentrated mass region, it is deflected. While it is moving through the empty space, no deflection. Okay, this is all about it. So he got some idea about the structure. So on the basis of his conclusions, he put forward an atom model, which is called a Rutherford atom model. Let's discuss the postulates of that atom model. Three postulates on the basis of three conclusions. There is a positively charged center. He already concluded that positive charge is concentrated in a small space. That means that positively charged center in an atom is called a nucleus. So he given the term nucleus. So who is discovered nucleus? Rutherford. And nearly all the mass of an atom resides in the nucleus. That means nearly all the mass of an atom is not the 100% of the mass of the atom, 90 or 98% like that. Because as the electron also possesses a negligible mass, but electron is not the part of nucleus. So nearly all the mass of the atom is contributed by the nucleus. Clear? While the mass of the electrons outside the nucleus are negligible. Because of that, it is clear mentioned like this. Not complete mass, but nearly all the mass. Clear. Second is the electrons revolve around the nucleus in the circular path. He given a clear idea about the interaction between the electrons and protons. Because as we know that electrons and protons have an attractive force between that. While the electron and protons should not be physically interact, or it should not be hit together. That means the electrons are revolving around the nucleus. You can observe that if you want to revolve a stone in a circular path, what will you do? Just take the thread and tie it and hold in your one hand, hold in your hand, and just rotate your hand so that the stone will revolve in a circular path. Because there is an interaction between your hand and the stone. Similarly, there is an attractive force between the electron and proton. Because of that, the electrons are revolving the circular path around the nucleus. What is the reason? The electrostatic force, the force between the electrons and the protons. And the size of the nucleus is very small as compared to the size of the atom. That means the size of the nucleus, that means the mass and the charge is concentrated in a small volume. So most of the space of atom is empty. That means the size of the nucleus is very much small compared to the size of the atom. So his model can be compared with the solar system. That means like this. This red region is representing nucleus, and the electrons are revolving in a circular path. Similarly, like a sun is at the center acting as a nucleus, and the planets are like electrons. It can be compared with the solar system or planetary system. Clear? So this is according to the Rutherford structure of. Let's sum up that one. What is the main thing? He said that mass and positive charge located in a small region called the nucleus, and electrons revolving in a circular path. That's all. But it has some limitation, drawbacks according to his model also. It can't explain the stability of an atom. According to his model, electrons are revolving around the nucleus. As per the model, the orbital revolution of electrons around the nucleus is not stable, as the revolving electron in orbits will undergo acceleration and emit energy. Whenever an object, a charged particle revolving in a circular path, it undergo the acceleration, means it is decreases its speed because of some friction, other forces. And as it go under acceleration, it emits energy. As it emits energy, what will happen? You can see the blue sphere I have represented as a nucleus. So as an electron is revolving in a circular path, it reduces its speed. As the speed is reduces, the radius of the circular path will be decreases slowly. It will be move like this. And finally, what will happen? It hits on the nucleus, fall on the nucleus. So in the undergo acceleration, this result the loss of energy, and they will ultimately fall into the nucleus, which means atoms become unstable. Especially in case of charged particles, while it is revolving in a circular path, due to the electromagnetic interaction, it undergoes acceleration, means it emits radiant energy. It has some energy, because of that it is revolving. While it emits energy, the radius of the circular path will be reduced. Slowly it will fall on the nucleus. That means when electrons fall on the nucleus, means atom become unstable. But we know that atoms are stable. If the atoms are unstable, means the matter does not exist as in this form. So, but atoms are stable. That means Rutherford model can't explain the stability of atom. But don't worry, it is explained by Bohr's model of atom. That is the final model of an atom, or last model of an atom we are going to study in this chapter. This is the two postulates. Only certain or special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in these discrete orbits, electrons do not radiate energy. So according to this theory, it was clearly mentioned that one orbit, this is the nucleus suppose, and this is the first orbit suppose, and the second orbit will not be like this. It will be like this. Another orbit will be like this. That means there is a gap between each orbit, not continuous orbits instead of discrete orbits. So while electrons revolving in this discrete orbit, these electrons do not radiate energy. This is the explanation given by the Niels Bohr to overcome the drawback of Rutherford model of an atom, or to explain the stability of the atom. And moreover, these orbits are called energy levels. The orbits or shells are called energy levels. That means the energy of electron revolving in this orbit will be different from this one, and different from here. That means the continuous path is not allowed. That means electron do not radiate energy. Only the electron revolving in this third orbit can only revolve in that orbit. It cannot radiate the energy and come to the second orbit by spontaneously. Clear? That is we have to remember. And the orbits or shells are represented by letters K, L, M, or the number N like that. K, L, M, N, or the numbers like N equal to 1, 2, 3, 4 like that. Let's see. This is the nucleus. Okay. Nucleus. And this is the first orbit or shell. This is called K. Okay. And the second one is this, L. And the third one is M. And the fourth one is N. Or we can say that N equal to 1, 2, 3, 4. So the energy of the electron revolving in different orbits are different. There is no continuous energy orbits. There is no continuous orbit. So this is all about Niels Bohr model of atom. Okay. And there is some rules for distributing the electron in each orbit that we will discuss in the next video. Okay. Now let's summarize the properties of the subatomic particles. We already discussed two kinds of subatomic particles called protons and electrons. They are charged particles. Protons present in the nucleus and electrons around the nucleus, outside the nucleus. But one more kind of particles, which are not charged particles, but still exist inside the atom. Such types of particles are called neutrons. So there are a total of 3 kind of subatomic particles present in the atom: electron, proton and neutron. Electron is represented by simply, we already discussed, P, and neutron is represented by N. And electron is located around the nucleus, while proton and neutron both are inside the nucleus. And the relative charge, we can write it as -1 and +1. Not the exact charge, okay. In case of neutron, the charge is 0 because neutron is chargeless particle. The exact charge is 1.6 into 10 raised to -19. Minus 1.6 into 10 raised to -19. And this is, plus, okay. Plus 1.6 into 10 raised to -19. Clear? That means the strength of the charge, magnitude of the charge equal, but the sign is opposite. Because of that, the relative charge we got +1 and -1 while we were taking the ratio. It is 0. And the relative mass is 0.00005, while the relative mass of proton and neutron are approximately equal 1. Actual mass is 9.11 into 10 raised to -31, that is the mass of the electron. And in case of proton and neutron, 1.67 into 10 raised to -27. Never think that it is exactly equal, it is a rounded value. There will be a small negligible difference in their mass of proton and neutron, not exactly equal, but rounded value is same. Okay. So this is all about the properties of the subatomic particles present in the atom. This is C is representing the unit of the charge. So the unit of electric charge is coulomb. Okay. So that is this here represent. This is kilogram. Okay. So finally, let's see the 3-dimensional view of the structure of the atom. Here in the Bohr model of atom, we have drawn only the 2-dimensional nucleus and the electrons revolving in the circular path. That is a 2-dimensional view. Let's see the 3-dimensional view of the atom. This is the 3-dimensional view. Here, this center portion, you can see that is one yellowish and one blue. 2 types of spheres are there. And these 2 particles represent neutron and proton inside the nucleus, while this red is electron. It's not that all the electrons revolving in the same plane. Just all the path, you can see that in the 3-dimensional view. You can see here, one electron is revolving here in this direction, another electron in the same orbit. Okay, orbit is not different, but in the different direction. So the direction, one electron is revolving like this, another electron is revolving like this in the same orbit. That means it is not 2-dimensional, 3-dimensional. So this is all about the structure of the atom. So I'm going to wind up this video, and in the next video I will discuss the electronic distribution and some other terms related to the atoms. Okay. So that's all for today. Thanks for watching.